Good morning, my dear students. Today I am going to give a speech on various laws governing UV visible spectroscopy. So the very important laws governing the UV visible spectroscopy is Beer's law, Lambert's law and Beer-Lambert's law. So first let me tell about the definition of Beer's law, or what is the definition of Lambert's law. We will start from the Lambert's law. Lambert's law states that the relative decrease in intensity of the emergent light with a slight increase in thickness of medium is directly proportional to the intensity of incident light. The relative decrease in intensity of emergent light in the sense transmitted light, with a slight increase in thickness of medium is directly proportional to the intensity of incident light. It is given by the formula minus di by dt is directly proportional to I0. Minus di by dt, that shows that the relative decrease in intensity of emergent light with a slight increase in thickness of the medium is directly proportional to intensity of incident light. Now, when I have this minus di by dt is proportional to I0, now if I want to equalize this equation, minus di by dt is equal to mu into I0. I am just equating this with a proportionality constant called mu. Now, just if I go for reciprocal of this equation, I am just making the reciprocal of the equation. Then instead of minus di by dt, it becomes minus dt by di is equal to 1 by mu into I0. Right? Now, if I want the thickness, because Lambert's law is concerned only with the thickness of the medium. So, I want to get only this dt factor. So, what I used to do, minus dt is equal to di will go here. So, di divided by mu into I0. Di divided by mu into I0. Right? Now, this is the equation I am getting over here. So what I am doing, I just try to integrate with respect to thickness T. If I just integrate this equation with respect to thickness T, so what will happen? Minus T is equal to 1 by mu. I just take the mu out here into natural log of IT plus C. Is it clear? So minus T is equal to 1 by mu natural log of IT plus C. Because this is also I, this is I0. So therefore IT by I0, I am giving natural log of IT plus C. So this is a very important equation 1. Now if I am using the thickness of the medium, suppose say for example this is the first thickness, this is the second thickness, this is the third thickness. If I pass the intensity of the incident light and this is the intensity of the transmitted light coming out emerging from the medium. So if the thickness T is equal to 0, if I put thickness T is equal to 0, so instead of T I am putting 0, then 0 is equal to 1 by mu into natural log of I0 plus C. Instead of T I will be getting I0 plus C. So I will get the factor of C here. C is basically an integration constant. C is equal to minus 1 by mu into natural log of I0. Now this is the equation number 2. If I use this equation 2 in equation number 1, I used to get this value minus T is equal to 1 by mu into natural log of IT minus 1 by mu into natural log of I0, because the C factor I am introducing here. But I need, this is for the value of minus T. So what I used to do, I just convert for plus T. So when I put plus T, this term will come in the beginning and this term will go in the back. So what will happen? T is equal to 1 by mu natural log of I0 minus 1 by mu natural log of IT. In other words, if I take this, all these factors as common, 1 by mu, natural log, in all these cases they are common. So what will happen? T is equal to 1 by mu natural log of I0 by IT. Right? So this is the formula I am getting. Now if I want to convert the natural log into normal logarithmic scale, so what I used to do, I have to multiply with the 2.303. So therefore T is equal to 2.303 divided by mu into log of I0 by IT. This is the equation I am getting finally. In other words, we can say log of I0 by IT is equal to, this log of I0 by IT is called absorbance. Log of I0 by IT is equal to mu T divided by 2.303. Because mu is a proportionality constant, 2.3 is also a constant. So instead of mu by 2.303, we are taking as a single term, that is K. So what will happen? A is equal to log of I0 by IT, which is equal to KT. So this is the final equation for Lambert's law. This is how the Lambert's law has been derived basically, right? A is equal to log of I0 by IT, which is equal to KT, right? Now what is this A? What is this terminology A? When I want to discuss about this terminology A is the absorbance, mu is the absorption coefficient, and T is the thickness of the medium, and K is the extinction coefficient. Now what is called Beer's law? The second important aspect, what do you mean by Beer's law? Beer's law states that the absorption of UV radiation is directly proportional to concentration of absorbing species. I repeat it. Beer's law states that the absorption of UV radiation is directly proportional to concentration of the absorbing species. In other words, A is equal to log of I0 by IT, which is equal to mu C divided by 2.303. There in the Lambert's law we used thickness, here in Beer's law we are using concentration as a factor. So therefore A is equal to log of I0 by IT, which is equal to Kc. This is the equation we are getting. Now I am just combining both these Beer's law and the Lambert's law. If I want to go for the derivation of a combination of both the Beer's law and Lambert's law, what I used to do, say for example I0 I am passing, intensity of incident light, this is the thickness one, IT1, IT2, and this is the thickness IT, and before IT this is ITn minus 1, and before this here it will be ITn minus 2 if you are coming from the back side, right? Now log of I0, from this equation if you look at this, log of I0 minus log of IT1 is equal to Kc1. This is the first thickness. This is the first thickness. Log of I0 minus log of IT1 is equal to Kc1. Then log of IT1, second one, log of IT1 minus log of IT2 is equal to Kc2. Similarly, log of IT2 minus log of IT3 is equal to Kc3. Right? Then log of IT, from the backwards if I am calculating, log of Itn minus 2 minus log of Itn minus 1 is equal to Kcn minus 1. Similarly, log of Itn minus 1, this one, log of Itn minus 1 minus log of It is equal to Kcn, n number of thickness, right? So this is the formula I am getting. Now you have to add all these terminologies, all the equations you have to add. So minus log of IT1 plus log of IT1 will automatically get cancelled. Minus log IT2 plus log IT2 will get cancelled. So everything will get cancelled here. Minus log IT3 and log of Itn minus 2 will also get cancelled. Similarly, minus log Itn minus 1 and plus log Itn minus 1 will get cancelled. So what is left out? The first term log I0 is left out and the last term minus log It is left out. So therefore log I0 minus log It is equal to Kct. Right? Why we are giving Kct? C is for concentration and T is for thickness. Okay. So if I use this term, so what will happen? Log of I0 by It is equal to Kct, which is nothing but absorbance. So simply in layman's language, absorbance is equal to ABC. This is the Beer-Lambert's law. This is also the Beer-Lambert's law. A is equal to log of I0 by It, which is equal to Kct. In layman's term, A is equal to ABC, where B is the thickness of the medium and C is the concentration of the sample and A is the absorptivity. This capital A is the absorbance and the small a is the absorptivity of the sample. So what we used to say, if this absorbance is equal to absorptivity, if the concentration and the thickness are unity. So concentration can be expressed as either 1 gram per 100 ml or it may be 1 moles per liter, and thickness is basically 1 centimeter. If the concentration is expressed as weight per volume percentage, the proportionality factor A is called specific absorbance. That is a very important thing. The small a is called absorptivity, but since we are measuring the concentration with a specific unit, so this absorptivity can be either called as specific absorbance or molar absorbance, right? So therefore what will happen, if the concentration is expressed as weight per volume percentage, the proportionality factor A is called specific absorbance, which is given by A 1% 1 centimeter value, or sometimes we call them as specific extinction, which is called as E 1% 1 centimeter. So most of the Indian pharmacopoeia, for most of the drug molecules, they used to express the values in A 1% 1 centimeter value for most of the drugs. If the concentration is expressed as molarity, that is nothing but 1 moles per liter. If you are expressing the concentration of the sample in molarity, the name of the A, the name of the small a, absorptivity, is called as molar absorptivity. That is given by a terminology called epsilon. right, which is given by a terminology called epsilon, or sometimes we also call it as molar extinction coefficient, right. So this is the very important aspect. Whenever you are going for any calculation, you should be in a position to remember that the absorptivity is a vague general term. So when the concentration is expressed in gram per 100 ml or moles per liter, if it is expressed in gram per 100 ml, in that case we are mentioning this absorptivity as specific absorbance or specific extinction. When the concentration is expressed in moles per liter, then we are expressing the absorptivity as molar absorptivity or molar extinction coefficient. So these things we are using in different calculations. And if you want to correlate this molar absorptivity versus your specific absorptivity, so what we can say here, molar absorptivity is interrelated by a terminology is equal to A 1% 1 centimeter into M divided by 10. M is the molecular weight of the sample. Okay. So this is an equation relating both the molar absorptivity and the specific absorbance. So this is what all about the derivation and the definition of Beer-Lambert's law.
Thank you, my dear students.